Hi everyone, good evening. Welcome to Numeric Learning. In today's video, we will be solving the NCERT Exemplar Exercises of the third chapter, which is pair of linear equations in two variables. So there are 4 exercises in total and a variety of questions compared to the NCERT exercises. These questions are of huge variety and there is a lot of diversification. There are MCQ questions. So unlike your NCERT questions, you don't have continuous questions of the same pattern. For example, if you remember in NCERT, we were solving a set of questions only by elimination method. We were solving another set of questions only with substitution method. So the pattern, it was not diversified. So here you will have diverse pattern of questions. Let's get started. So this is exercise 3.1 of Exemplar. The first question is, graphically, the pair of equations, you are given two equations, they represent the two lines which are intersecting at one point, intersecting exactly at 2 points, coincident or parallel. Okay, so first of all, we know how to take the ratio of the coefficients, that is a1 by a2, b1 by b2, c1 by c2, and based on that we already know how to identify if a pair of linear equations has unique solution or infinitely many solution or no solution. But here in the question you are asked graphically, so let's do it graphically. So in order to plot the straight lines of both these linear equations, we need to have points, we need to find out the x and y coordinates. So let's get that first. The first equation is 6x minus 3y plus 10 equal to 0. So what is 6x plus 10 is equal to 3y, or I can write y is equal to 6x plus 10 by 3. Right? We can get at least minimum 2 points. Okay. So if x is equal to 0, what will be a y? Y will be 10 by 3. This is the first thing. And if x is minus 1, for example, just substitute minus 1 here. So you'll have minus 6 plus 10 by 2, which is 4 by 3, which is 4 by 3, right? So this second point is 4 by 3. You can just put these points in a table. Okay, if you're asked graphically, you should only do graphically. Just if you plot these two equations in the form of straight lines, then you will be able to know whether the two lines are intersecting at one point, whether they are coincident or whether they are parallel. Let's take the second equation now. So you have 2x minus y plus 9 equal to 0, or I can write y is equal to 2x plus 9 if I take y to the other side. So let's take x and y and take any 2 points. Say for example, if x is equal to minus 3. If x is minus 3, what will you have? Minus 6 plus 9. So 9 minus 6, y will be equal to 3. The next point, if x is equal to minus 4. Right? If x is equal to minus 4, so 2 into minus 4 is nothing but minus 8 plus 9. 9 minus 8 is just 1. Okay, so these are the 2 points of the two equations. Now let us plot this. I've got a graph. For the first line, let's plot. What is this value? 10 by 3 is nothing but 3.3. Okay, and 4 by 3 is 1.3. Okay, so that it's easier for me to plot it. Now let us draw the first one. 0, 3.3. So 0, 3.3 will be here, somewhere here. Okay, and minus 1, 1 by 3. Minus 1 and 1.3 will be somewhere here. Okay, so let me draw a straight line joining these 2 points. Correct? I hope you're able to see this. And the second point would be for the second line. So this line equation is nothing but, so this is the first, this is the line representing the first equation. So we'll write the equation here. Okay, so this equation is nothing but 6x plus, I'm not able to write it here. It's but you should be able to write. Okay, so this is nothing but this first line is 6x plus 10 equal to 3y. Okay, I hope you should be able to write this, right? Okay, for the next one, minus 3 comma 3. Let's mark the points. Where is minus 3 comma 3? It's here. Okay, this one. And the next point is minus 4 comma 1. So minus 4 comma 1 will be here. So now let's draw a line joining the 2 points. Right? Now what do you see here? So I should have been more accurate here. Right? Okay. Now what do you see? What do you see about the 2 lines? Let's mark this also. What is it? Y equal to, this equation is nothing but y is equal to 2x plus 9. Always make sure whenever you're drawing a line representing a specific linear equation, always write that equation on top of the line. Okay, because the teachers will not know which line is representing which linear equation. So now what do you see? You see that both the lines are parallel to each other, right? So the answer is parallel line. So this is your answer. Okay, D, parallel lines. So here you are just graphically plotting both the equations, getting the x and y coordinates and drawing the lines, straight lines. Whenever you have a linear equation, it's always going to be a straight line graph. Plot both the lines and see if it is intersecting, or is it coinciding or overlapping one over the other, or is it parallel, right? That's all. That's your first question. Let's move on to the second question. Yes, here the question is, the pair of equations, you are given 2 equations, has a unique solution, exactly 2 solutions, infinitely many solution, or no solution. So first of all, from the equation you can write, what is the equation? X plus 2y plus 5 equal to 0 is the first equation. The second equation is minus 3x minus 6y plus 1 equal to 0. Now by looking at it, what is your A1 by A2? You have to analyze your A1 by A2. A1 is nothing but the coefficient of x in the first equation. It is just 1. A2 is minus 3. Okay, this is your A1 by A2. What is B1 by B2? It's nothing but 2 divided by minus 6. So 2, this is nothing but minus 1 by 3. What's your C1 by C2? As you can see, your C1 by C2 is this one, the coefficient here. So which is nothing but 5 by 1. So from these 3 values, what do you see? Therefore, A1 by A2 is equal to B1 by B2, but this is not equal to C1 by C2. So this is the condition wherein the lines are parallel. Okay, so because you have your A1 by A2 ratio is equal to B1 by B2, but that is not equal to C1 by C2, what do you infer? This is a condition when the lines are parallel. And when the lines are parallel, we do not have any solution. So no solution. Okay, and when there is no solution, what do you call about the system of these equations? They are called as inconsistent in nature. This system of equations are inconsistent. Okay, so what is the answer? No solution. Option D. Okay, so always remember, whenever you are dealing with these kind of questions, you should always remember the 3 conditions. What are the 3 conditions? The first one is for unique solution. A1 by A2 is not equal to B1 by B2. For infinitely many solutions, the lines will be coinciding. All the 3 ratios are equal. And the third condition is nothing but the first 2 ratios, A1 by A2 and B1 by B2 will be equal, but that will not be equal to C1 by C2. That's your third condition, which is no solution. So these 3 conditions, if you know, you can solve a lot of problems based on this. Okay. Let's move on to the third question. If a pair of linear equation is consistent, then the lines will be, so whenever you talk about consistency of a system, okay, the system is said to be consistent, then it means they have some solution or many solution. There are 2 scenarios possible. One is it will have unique solution. That means one solution. Or it will have many solutions. Whenever a system of equation is giving you or has one solution or many solution, then the system is said to be consistent. So for unique solutions, how will the graph be? The lines will intersect at a point. So it will be intersecting lines. And when it has infinitely many solutions, in that case, the lines will be coincident. Okay, so for a system to be consistent, it can either have coincident lines or intersecting lines. Either of this is possible, intersecting or coincident. So which is the option? It's option number C, intersecting or coincident. Okay. Now moving on to question number 4. You are given a pair of equations y equal to 0 and x is equal to minus 7, y equal to minus 7. You have to say whether y equal to 0 and y equal to minus 7 has one solution, two solutions, infinitely many solution or no solution. So let us see how the graph looks like. So here, if we just suppose this is the graph, okay, and here you have got your x-axis, this is your y-axis, this is 0. Where will you plot y equal to 0? So y equal to 0 will be your x-axis. Okay, this is nothing but y equal to 0. Remember it. Okay, y equal to minus 7. Where will be your y equal to? So this is nothing but in your y-axis. If you're marking, this is your positive x-axis, right? 1, 2, 3. This is your negative x-axis, minus 1, minus 2, minus 3. This is positive y, 1, 2 and 3. And this is negative y, that is minus 1, minus 2, minus 3. It will go on. And here if we have minus 7. So y equal to minus 7 will be parallel to your x-axis. It will pass through minus 7 and it will be parallel to your x-axis. So this equation, this particular line, okay, the line passing through y equal to minus 7 and parallel to x-axis, this line is y equal to minus 7. Always remember, y equal to 0 is your x-axis. Okay, x equal to 0 will be your y-axis. So this will be x equal to 0 line. Okay, now what do you say about these two lines? It is parallel, right? Therefore, you can say these are parallel lines. And will parallel lines have any solution? No. Therefore, they have no solution because they'll never meet. So, no solution. So, which is the answer here? D, no solution. Right? I hope you understood. Let's move on to the next question. 5th question. The pair of equations x equal to a and y equal to b graphically represents lines which are parallel, coincident, intersecting at b comma a or intersecting at a comma b. Let's draw this again and try to understand. So suppose these are your x and y axis. So x and y axis. So x equal to a. Okay, so for example, this is a point which is a, and here you have positive y axis, this is b. X equal to a will be a line which will pass through x equal to a and it will be parallel to y axis. So this will be the line. Okay, this will be your line for x equal to a. This will be your line for x equal to a. Remember it. It passes through x equal to a and it's parallel to your y-axis. Y equal to b will be a line which passes through y equal to b and it will be parallel to your x-axis. Right? So, this line passes through y equal to b. Okay. So, let's mark it here. So, this line is y equal to b and it is parallel to your x-axis, right? So, what will be this point? This point will be a comma b. So, the two lines will intersect at a comma b. So, what is your option? It's option number D. Okay, so whenever you have two equations, x equal to a and y equal to b, a can be any positive number. So if, for example, if a is 5 and y equal to b, instead of b it is 7. Okay, a is 6 and b is 7. For example, in place of a, if you are given 6, okay, in place of b, if you are given 7, you can directly tell where will these two lines intersect. So for example, if it is x equal to 6 and y equal to 7, they will intersect at 6 comma 7. So like that you can, based on the result of what you are studying, okay, based on this solution, you can write other answers immediately. Okay, so a is a positive number, it could be any positive integer, y equal to b, b can be any positive integer, then they will always intersect at a comma b. Okay, so this is a result which you can make a note of. I hope you understood. Let's move on to the sixth question. Okay, for what value of k do the equations 3x minus y plus 8 equal to 0 and 6x minus ky equal to minus 16 represent coincident line? So you should know the condition for coincident line. Okay, what is the condition for coincident lines? It is nothing but a1 by a2 will be equal to b1 by b2 and this ratio will be equal to c1 by c2. So based on the given equations, what are the given equations? 3x minus y plus 8 equal to 0 and you are given 6x minus ky minus 16 will come here plus 16. So both the equations should be in the standard format. Now let us write what is a1 by a2. It is 3 by 6. Okay. Should be equal to minus 1 by minus k. What am I writing here? I am writing the coefficients of x. Okay. This 3 is a1, 6 is a2. Again, b1 and b2 is minus 1 and minus k. c1 and c2 are 8 and 16. Okay, 8 and 16. Okay, so when you cancel it, what do you get? So here you will get 1 by 2. Here also you will be getting 1 by 2. So what do you get now? So 1 by 2 is equal to 1 by k, minus minus will get cancelled, is equal to 1 by 2. So take any two equations, cross multiply. So what do you get k as? K will be equal to 2. So in order for these two equations to be representing a coincident or an overlapping line, the value of k has to be 2. Okay, so if you put k equal to 2 here, then these two equations will represent coincident line. Okay, what do you mean by coincident lines? So you have one line and the other line will be coinciding, okay, overlapping the previous line. So this is what is called the coincident lines. Clear? Let's move on to the next question. Seventh question. If the lines given by the two equations are parallel, then find the value of k. So all of these questions are MCQ questions. Again, you should know the condition for parallel lines. What is the condition for parallel lines? It is nothing but a1 by a2 will be equal to b1 by b2, but these ratios will not be equal to c1 by c2. Okay. Now, based on what is given 3x plus 2ky minus 2 equal to 0 and the second equation is 2x plus 5y minus 1. I am bringing it to the left hand side is equal to 0. Now, let us write what is a1 and a2. It is 3 by 2. Should be equal to 2k by 5. I am just writing the coefficients of y in both the equations. And this will not be equal to c1 by c2. So we are not bothered to write. Either ways, it's not equal. So from these two equations, cross multiply. How will you cross multiply? Just cross multiply here. Okay. So 2 2s are 4. 4 times k will be equal to 15. So what's k equal to? 15 by 4. That's your answer. So do we have a 15 by 4? So it's option C. Okay. So it's very easy provided you know those three conditions for unique solution, for infinitely many solution, and for no solution. Okay, so let's move on to question number 8. Yes, the value of C for which the pair of equations will have infinitely many solution. Again, let us first write the condition for infinitely many solutions. So whenever you have to have infinitely many solutions, the lines have to be coincident, right? So all the three ratios have to be equal. So A1 by A2 should be equal to B1 by B2, and this will be equal to C1 by C2. You have to find the value of C for which the pair of equations will have infinitely many solutions. So let's just plug in the values. So what is A1 by A2? Here. So from the diagram, from the equation, can we directly write C by 6. Okay. A1 by A2 is C by 6 will be equal to what is B1 by B2? Minus 1 by minus 2. Should be equal to, again, minus 2 by minus 3 or 2 by 3. Okay. Now, if you take the first two ratios, cross multiply, again this minus minus will get cancelled. What do you have? You have 2C is equal to 6, C is equal to 3. Okay, this is your first value of C. Now let us take the first and the third ratio in order to check the value of C. So you are taking C by 6 is equal to 2 by 3. Cross multiply, you have 3C equal to 12. C is equal to 12 by 3, which is C is equal to 4. Now for one single unknown variable C, that is the coefficient of X, you are getting two values. So you cannot, which means it's not possible, since C has two values here, right? C, this coefficient of X, what you are getting is, you are getting two different values of C. Okay, so you can write, since C has two values, which is not possible, right? Which is not possible. C can have only one value. Therefore, no such values are possible. No values are possible. In order for the two equations to have infinitely many solutions. So the answer is no value is possible. Okay, that's your 8th question. Okay, so always check for both the ratios. Let's move on to the 9th question. So the 9th question is, one equation of a pair of dependent linear equation is given. The other equation can be. So this is nothing but you have to be clear about what they mean by dependent linear equations. Always remember, the condition for dependent linear equations is nothing but the same as that of the coincident line. Okay, coincident line, it's the same thing, which is all the three ratios, that is A1 by A2 should be equal to B1 by B2, and this will be equal to C1 by C2. So you have to find out one equation is given, which can be the second equation for the system of equations to be coincident. Coincident is also called as dependent linear equations. So let us check with the first two options. Okay, the first two options, that is, you have to check this equation with A, this given equation with B, this with C, and this with D. So let's write, okay, the first equation that is your given, that is minus 5x plus 7y minus 2 equal to 0, and your option A, which is nothing but 10x plus 14y plus 4 equal to 0. Here if you see the ratios A1 by A2, you have minus 5 by 10, okay, is equal to 7 by 14. Okay, if you see it's not equal, right? So you're getting, what are you getting here? Minus 1 by 2 is not equal to 1 by 2. So first equation is not correct. Okay, let's move on to the second equation, which is, again, the first one, that is the same with the second equation. So with option B, what is your option B? Minus 10x minus 14 by plus 4 equal to 0. Here if you see, just take the ratios. Again, minus 5 by minus 10. Okay, these two, this is the given equation, right? This is your given equation, the first equation. You have to find which one will it match. So these two, it's not matching. Now from the given equation and the second equation, we are just trying to match. So minus 5 by minus 10 is not equal to 7 by minus 14, right? So again, your negative will get cancelled. This is nothing but 1 by 2. Here it is minus 1 by 2. So option B is not the correct answer. Now let us check with option C. What is your option C? Minus 10x plus 14y plus 4 equal to 0. So what is your A1 by? So this is your A1. Okay, this is your given equation. Remember it. We are just comparing the given equation with all the other. So for the given equation, it's A1 is minus 5 by minus 10. And the second one will be 7 by 14. Yeah, both these are correct. And the third one, it's not equal because it's minus 2 by 4. Right? So the first one, you will get it as 1 by 2. This is 7 by 14 is also 1 by 2. But here it is minus 1 by 2. So this is not equal. So again, option C cannot be the right answer. Now let us check the given first equation with the third one. That is 10x minus 14y plus 4 equal to 0. Okay. So what is your A1 by A2? That is minus 5 by 10 should be equal to 7 by minus 14. This should be equal to minus 2 by 4. Okay, I took the A1, B1, C1 from the previous equation. So here what do you see? This is minus 1 by 2. Okay, this is 1 by 2. Again, this is also equal to minus 1 by 2. This is also equal to minus 1 by 2. So our correct option is D. So the second equation will be option D. Okay, the first equation is already given to you. This will be the second equation. Only then the A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Okay, you'll be getting minus 1 by 2 in all the three ratios. And the since all the three ratios are equal, the lines are coincident or overlapping, the system is said to be dependent. One equation is dependent on the other equation. And the system is consistent and it has infinitely many solutions. So, I hope you understood. Now, let us move on to the 10th question. Yeah, you have to find a pair of linear equation which has a unique solution x equal to 2 and y equal to 3. So, in each of these equations, you will have to plug in the values. Let us do that. Okay. So, for the first equation, you are given x plus y equal to 1 and 2x. X is nothing but 2, right? So, if you just plug in the value 2 plus y is nothing but minus 3 is equal to 1. Is it equal to 1? Yes. 2 minus 3 is minus 1 is equal. It's not equal to 1, right? And the second one is nothing but 2x minus 3y is equal to minus 5. So here what will you have? In place of x, you will have to just put x equal to 2. Minus 3 into minus 3. Let's see if it is equal. So it's nothing but 4 plus 9, which is equal to 15. This is not equal to minus 5, right? So x equal to 2 and y equal to minus 3 cannot be cannot be the unique solution of the first pair. Let us check with the second pair. Option B. What is it given? 2x plus 5y should be equal to minus 11. Just substitute 2 into 2 plus 5 multiplied by minus 3. So what is it? 4 minus 15 will be equal to minus 11. This is equal to minus 11. Right? Now let us check the other equation, which is 4x plus 10y equal to minus 22. What is 4 into x is 2 plus 10 multiplied by minus 3. So it is 4 to the 8 minus 30. It is equal to minus 22. Right? So for option B, both the values are correct. So if you take the ratios now, what do you see here? A1 by A2, in order for the equation to have unique solution, okay, your A1 by A2 should not be equal to B1 by B2, right? If you take these two, what do you have? A1 is nothing but 2 by 4 should not be equal to 5 by 10, but these two are equal. So it cannot be the unique solution. Okay. Now let's take option number C. What is option number C? 2x minus y equal to 1. And 3x plus 2y equal to 3x plus 2y equal to 0. Okay. Now let us just substitute x and y. So what will you get? 2 into 2 is 4. 4 minus 3. Right. So here what do you get? Let me just erase these other equations so that I have some space. So what would you get here? 2 multiplied by 2 minus of minus 3. So what would you get? 4 plus 3 equal to 7. It's not equal to 1. So this is not satisfying. The other one is 3 multiplied by x value is 2 plus 2 multiplied by y is nothing but minus 3. So again this is 0. Right? 3 2s are 6 minus 6 is 0. So this is complying, but x and y should be both satisfying both the equations. Right? Let's go to option number D. What is the D option? X minus 4y should be equal to 14. So let's substitute. X is 2 minus 4 into minus 3. What is it? 2 plus 12 is equal to 14. Yes, x and y is getting satisfied. What is the next one? 5x minus y should be equal to 13. Okay, so 5 multiplied by x equal to 2 minus of minus 3. This is nothing but 10 plus 3, which is equal to 13. Again, this is also satisfying. So x and y values that is given, right? X equal to 2 and y equal to 3. Both these two values of x and y is satisfying both these equations. Now let us compare A1 by A2. What is A1 by A2 here? 1 by 5. What is B1 by B2? Minus 4 by minus 1, which is nothing but 4 by 1. Again, A1 by A2 is not equal to B1 by B2. So this condition is also satisfied. Right? A1 by A2 should not be equal to B1 by B2 in order to have unique solution. What do you mean by unique solution? The lines will intersect at a point. So the correct option is D. So D is that system of equations wherein the values of x is equal to 2 and y equal to minus 3 are being satisfied in both, as well as the condition for unique solution, that is your A1 by A2 being not equal to B1 by B2, both the things are getting satisfied. Okay, so option D is the correct answer. Clear? Okay. So you have to actually plug in the values in each of the pair of linear equations and see whether x equal to 2 and y equal to minus 3 is satisfying both. If they are satisfying both, then possibly that is a solution for this system of equation. Then you should check, okay, in order for the system to have unique solution, whether A1 by A2 is not equal to B1 by B2. That also you should check. Okay. Let's move on to the 11th question. Yeah. You are given if x equal to a and y equal to b is the solution of the equations x minus y equal to 2 and x plus y equal to 4. Okay, you are given x is nothing but a. So let's plug x equal to a and y equal to b equal to 2 and then a plus b equal to 4. Find the values of a and b. Just add them. So what would you get? Minus b plus b would get cancelled. 2a equal to 4 plus 2, 6, a equal to 3. Okay, so let this be equation 1. Let this be equation 2. So you can put a equal to 3 in equation 1. So what do you get? 3 minus b equal to 2. Okay, so what is b equal to? 3 minus 2, which is 1. Therefore, b is equal to 1. So what is the value of a and b? The values of a and b are asked 3 and 1 respectively. 3 and 1. So again here also I was doing the same thing like the previous question. I was just plugging in the values of a and b and then solving it. Okay. So I hope you understood. Let's move on to the 12th question. Yeah. Aruna has only 1 and 2 rupee coins with her. If the total number of coins that she has is 50 and the amount of money with her is rupee 75, then find the number of rupee 1 and rupee 2 coins. Again, this is a very good question. Let the number of rupee 1 rupee coins, let it be your x. Okay. And the number of 2 rupee coins, which we don't know, let it be y. According to the question, we don't know how many 1 rupee and how many 2 rupee coins she has. You are given the total number of coins that she has is 50. So you are given x plus y is equal to 50. This is your first equation. The second equation is the amount of money with her is 75. So 1 times x, like we don't know how many. If the number of 1 rupee coin is 10, if x is 10, then the value is 1 into 10, which is 10 rupees. If the value of y, each coin, okay, there are, so suppose number of 2 rupee coin is 20, then 2 into 20, the total value will be 40 rupees. So what are you doing here? Each coin value multiplied by the number of coins. Okay, so 1 into x will be giving you the total amount of money that is equivalent to those 1 rupee coins plus 2 times y. This will be giving you the total amount of money. What is the money she has? 75. This is equation number 2. You have to just solve 1 and 2. What we can do is we can subtract 2 minus 1. So what is equation 2? X plus 2y equal to 75. X plus y equal to 50. We are just subtracting. So just change the sign. This plus x minus x will get cancelled. 2y minus y is just y is equal to 25. Okay, so you're getting y is equal to 25. What is your y? Y is the number of 2 rupee coins. Okay, so let's put y equal to 25 in equation 1. So what do you get? X plus 25 is equal to 50. Therefore, x is equal to 50 minus 25, which is 25. Okay, so you can write down. Therefore, the number of 1 rupee coins is equal to 25 and the number of 2 rupees, okay, you can mark the symbol 2 rupee coins is also equal to 25, right? Okay, so that's how you have to do these kinds of questions, money related questions or coin related questions. Okay, let's move on to the 13th question. Yeah, the father's age is 6 times his son's age. Okay, so here let this be your father's age. Okay, This is your present age. Let this be the future age, that is many years later, and this is the past. Okay. This is the son's age. Let the father's age be X. You can write it as a sentence. Let the son's age be Y. So what is the given question? The father's age is 6 times the son's age. So according to the, you can write let father's present age be X years. Okay. And son's present age be Y. Okay, according to the question you are given, X is nothing but father's age is 6 times son's age. This is equation 1. 4 years hence, that means after 4 years, father's age will be X plus 4, son's age will be Y plus 4. Okay. What are you given? 4 years hence, the age of father will be 4 times the son's age. That means X plus 4, father's age will be 4 times 4 multiplied by Y plus 4. Okay, you have to find the press. So this is equation number 2. Right? We have to just solve equation 1 and 2. So what do you get here? X plus 4 is equal to 4Y plus 16. Let's substitute X as 6Y. So 6Y plus 4 equal to 4Y plus 16. 6Y minus 4Y is equal to 16 minus 4, which is 12. So 2Y equal to 12, Y is equal to 6. Okay, so Y is the son's age. Now put Y equal to 6 in equation 1. So you will be getting X equal to 6 times 6, which is 36. So we have got X equal to 36 and Y equal to 6. So you can write therefore father's present age is equal to 36 years and son's present age is Y. Son's present age is equal to 6 years. That's your answer. Okay, so this is how you have to solve age-related question. If something was given about the past, then you could have mentioned that as well here. Okay, for example, before 6 years before, if it was given, you can just write X minus 4 and Y minus 4. Okay, and then pick up those variables from here. And just whatever is given in the question, just translate it to your linear equation. Okay, so this is your exercise 3.1. 13 questions were there. I hope you understood. Please make sure you solve every question of your exemplar apart from your NCERT exercises. Okay, so we will be covering all these 4 exemplar exercises one after the other. Okay, make sure you do it, practice all of these questions, and yeah, see you all in the next video. Please do share this video with your friends. It will definitely be helpful. Happy learning and thank you.